Hello everyone, today I'm going to show you how production workloads work on Redu and how differently they work compared to AWS and Kubernetes. We're going to start small, one simple VM and a database, and then we're going to scale it totally to production grade deployment. So we're going to do clusters, we're going to do automated backups, and one special thing about the clusters that are only currently available on Redu compared to popular options. Alright, so for this showcase, I'm going to use Chatwoot. So all I'm going to do is go here and I'm going to clone it. So git clone and paste it here. Okay, so after it's done, I'm going to go to that folder. So Chatwoot, and I'm going to start Claude. Okay, and all I'm going to do is type deploy this to Redu. Alright, so the agent scanned the folder and it recommended me one large VM and to put everything on it. So for this case, I will not do it. I will tell it use mem16 flavor and also managed DBs Redis, because I need a persistent volume and it's easier to scale with managed DBs other than one big VM that will need to be reconstructed later, because when scaling, all persistent storage should be off cluster. Okay, so this is the agent firing the new plan. So you can see it here, and all I'm gonna do is just type go and wait for it to finish. Alright, so the deployment is done. Let's go and check it out. So if I go here, I have the URL to see if it's working. So I'm just gonna go here, copy it, and here in the new tab, I'm just gonna paste it. Okay, we can see that Chatwoot is working so far. So what I'm gonna do now is go to my terminal and I'm gonna say upgrade it to cluster. Okay. Alright, so Redu is able to transform this into a cluster. However, it needs a small NFS storage. So basically when you upload images, when you upload files and things like that, there needs to be some type of shared storage for all those cluster VMs to access. So I'm gonna allow it to create one small shared NFS storage for this. I'm gonna use for the cluster member size 3 times M1 mem16. I'm not gonna use large or 5 large because it has a lot of storage and that will make migration slow, because you need to snapshot those VMs. So, okay, I'm gonna just submit those 2 answers. And one thing here also is that if you're looking for high availability, at this stage you can tell it to always have 3 VMs live, and that way you will have high availability. So if one VM goes down, there is always going to be 2 that will serve. And cluster is fully done. As you can see, it fully deployed it. And let's go and check this new URL that's connected to that load balancer. So I'm just going to copy it. And here I'm gonna just go and do this. Okay, and we hit load balancer. So that will work. And if there is a lot of traffic going at the same time, it will spin more VMs. So let's go and see now what's built in UI. So in redu.cloud UI, you can see that there are 4 instances. So there is that Chatwoot that's gonna autoscale. This is the part of the cluster, as we can see here. We have Redis, we have database that's Postgres, and we have that media small server. If we go to clusters, we can see Chatwoot cluster, and here is that URL that I just entered here. And in snapshots, we have that source of truth for building the cluster. And in load balancers, we can see that load balancer that's serving this with the same domain. Okay. So there is two more things that I would like to do here. First of all, I would like automated backups. So I'm just gonna say, can you add automated backups for Postgres? All right, it worked, and it's really simple. Agent managed to do this very easily. So if we go here and we go, for example, compute and backups, here we will be able to see them soon. So this database will be backed up. I'm just gonna tell it to do one backup now. Can you do one backup now? So we have a backup here ready if we need it. But over the night we will get more, and it's gonna be on 14 days retention. Alright, so the backup is here, and if we go to virtual machines and backups, we can see it here. And we can easily just restore it if anything goes wrong with the database. Okay, now I want to show you something extremely cool. There is a big difference of how clusters work in redu.cloud compared to services like autoscaling groups on AWS or how Kubernetes work. And we have one big advantage in this case. We are able to mutate production clusters live. So I can mutate this with agents and it will reflect the entire cluster live. While on Kubernetes, it's immutable, so you will need to reconstruct the entire cluster from the image. Same for AWS. There are systems and workarounds around this, and big companies like enterprises usually have a lot of systems in place to help with those things if incidents happen, for example. But the big advantage here is that imagine that you're having a lot of users and there is an incident, something went terribly wrong. On Redu, you can mutate it live and stop the bleeding, so your team has more time to actually build those images or snapshots and to do a proper solution for this. While if you're using AWS or something like that, you will need to raise on-call people. They will need to go and to fix that on staging or somewhere, and only then they can push it to replace the current cluster or autoscaling groups in their case. So this is a very big advantage, and this is how agents can change how you can operate the cloud. Because by default, by design, all our primitives like clusters, VMs, and everything are mutable by agents. And also this is safe in a way, because only those with correct SSH keys can actually access and do this with agents. So it's not like you are giving this access to the entire company and everyone can do this. Only specific people that are in charge of that can actually do these mutations. So let me first show you a few examples of it. First of all, I do not want to manually fill out this, so I'm going to go to the agent and tell it, can you go and create an account for me on that hero? So only hero instances are mutable, but they'll spread to others. So that's the design here. Okay, it managed to do that. So if I go there and if I refresh this page without this onboarding, it's still there. And I think the agent told me that. So I'm gonna tell it disable that first public sign up for the first account. No, I just disable that public sign up. Alright, so it's done. Let's go and do this again. So if I go here, it finally asks me for this. Let's find that password and username that it created here. So this is the email. And password is this. Okay, this perfectly work. Okay, now let's go and test that incident resolving. So I'm gonna go to the agent and tell it, let's do a test incident. I want you to go to that hero and change .env var any to something wrong. So it breaks how this works. So I'm gonna make agent make a incident, and this is a common one because I mean pushing wrong env files or just forgetting to do things like this is common. So this should break this app. All right, so the outrage is there. So let's go and check, and we can see something went wrong. So first of all, imagine that this is happening on your live production. How would you fix it? I mean, this is how I would. I'm gonna go here and first tell it, go to that hero and debug the incident. I am getting, and I'm just gonna copy this text. Okay. Paste. And let's see what it's gonna return with. Okay, and it literally managed to do everything. So here is how the path that it took to see this. It saw that there is a different, less good known environment file, and that the Postgres is not correctly working because of that DB credentials. It checked that the database is actually down, and it wasn't, it was healthy. And it looked at app logs. So it knew that there was something bad with the database because it just read the logs. So now if I refresh this, it should work, and it's working. So this is how fast agent can solve this type of incidents. So now let's say that I'm happy with it, I'm happy with this state. So I just want to save that. So I'm just gonna tell it, okay, I am happy with the current state, update the cluster. And that's it. I have full production, I managed to deal with incidents, I have backups. If anything way worse happened, I could always go and restore backups, but it's timely. It's not that quick to do. So this is basically the power of Redu. And if you like to try something like this yourself, feel free. Register on redu.cloud, make an account, try it on some project. There is £200 of free credits for every new account, so it's basically no risk to try.